upgrade my Mac, okay, to this new version. I have trouble like even opening like a file, okay, almost like any application. Okay, I cannot open it. Just access cannot access the file. So as a result, okay, because I couldn't use PowerPoint at all, like the past 2 days, so I cannot, create a quiz. Okay, so I think I will get this issue resolved, hopefully these 2 days. So in other words, okay, the quiz 2 will be postponed to next week. Okay. 就是跟你们讲说，因为我从礼拜一开始 upgrade 的电脑以后，始终是用人用，就是这是我第一次哦 ，OK， 那个对习惯骂Microsoft， 对不对？第一次对 Apple 这么失望，就是说搞一个升级，结果一直所有档案一开，他就给你问说，就是卡在那个验证，就是这几个正在验证某个档案，然后就我要过去这2年，包括昨天我都没办法签公文，昨天我都没办法签，所以从头到尾会没办法唱，就是给你们会特别大，没办法用我们的包包，所以现在的 workaround now is copy the file to a different computer, use it for the class. Okay, but as I said, as a result, I think that we will have to postpone our quiz to next week. Okay, 我们就quiz 就会到下礼拜。但这个quiz, okay, this quiz is special because it's supposed to be given out today. Okay, so next week the quiz will be given at the beginning of the class. Okay, 我们尽快把它补正回来。所以这个 quiz 2在下个礼拜我们会在开始的时候就给，好不好？就不影响到我们后面的上课。我不想那个就是拖到最后面再给。Okay. Quiz 3 will be the week after next week. Okay, so it does not affect the quiz 3. Hopefully, I can get the issue resolved either today or tomorrow. Otherwise, when you are in computer science, computer industry, and you don't have a computer, you cannot do anything. So, okay. So back to our class. Okay, we were discussing about the determinant last time, right? So which slide did you end up with? So this one has been covered because this is like a part of these 3 things. Okay, part of this theorem. Okay. I think like I think we finished like up to this So this is about like we are if we find like elementary row operation or column operation, like what's going to affect the determinant. Okay. So the following proof like apply for row or column elementary operation. I mean row elementary operation we have to define carefully. For column elementary operation, they are just similar to row elementary operation. And because for determinant, whatever you do for the rows, I mean, you will have like a similar effect to the column. So basically, like it's not going to affect like if a property holds for like elementary row operation will also hold for column elementary operation. So the first, okay, from A, if we exchange any two rows together, then the determinant B will be the negation of determinant A. Okay, B is obtained from A by multiplying the row, okay, A by a non-zero constant C. And determinant B will be C times determinant A. If B is obtained from A by adding a multiple of the row to A to another row, okay, the third elementary row operation. Then, I mean, these two determinants will be equivalent. Okay, will be the same. Okay. Yeah. Basically, okay, most of the proof, as I said, are done by induction. Of course, some are easy. Okay, some of them are easy to do by the definition. Okay, but for like this switching two rows. Okay. Oh yeah. I think I talked about it. I use like size 2, right? As a baseline, and then I try to show you like by induction. When size is lower than K, this probably works because K qualitative good property, right? So I think for this one we've done that. For the second one, okay, the second one is actually relatively easy. Okay, so. This is okay, and say we multiply this row by the constant C, non-zero constant C. Okay, so let's say like this is AI1, AI2. AIN, okay, the ith row, okay, and then, okay, we want to show that determinant B will be the C times determinant A. I mean, this is relatively easy. We don't even need to use like the induction. Basically, we just do like just expect from the rows. Okay, because determinant B will be, C times AI1, CI1, right? Right? Because we already multiplied each element in this row by C, right? So plus C times AI2, CI2. Cross C times AIN times capital CIN, right? So every term here has a C, right? So we just like get a C out, and the rest will be AI1, CI1 plus AI2. CI2 plus AIN right? Inside is like that. And this one, according to the definition, is determined of A, right? You just expand like to get determined A from the ice road. That's like the formula, right? So this is like very, very easy. Okay? The third one, it looks tricky, but it's actually similar. It's similar. So, say this is row I, right? And this is, let's say we have a row J, A, J, 1, A, G, and okay, and then we modify this by say C and then add to this. Okay. Then what happens is that now we expand, okay, from this row. So let me see what we. Because after you multiply the i's row and add to the j's row, and the j's row, okay, will become aj1 plus c times ai1, right? Times cj1, right? Right? Actually, there should be a sorry. J plus 1 is like I've forgotten to write down those terms, but it doesn't affect the proof. And then plus plus the last one. Okay. J plus n and a j n plus c times a I n times c j n, right? Something like that. And if you try to, remove that, like carry out those parentheses and then rearrange this, what you're going to get is, J plus 1, AJ1 minus CJ1 plus negative 1, J plus n, AJN, okay, times CJN plus C times like the first term here, and all the second term, okay, here, and then you try to put the common vector outside, right? And then this one, according to our previous discussion, okay, this one, okay, actually, oh, I'm sorry, the C already include like negative 1 to the power, so it's my bad. I should. So this one, according to this theorem, okay, because I, J are different rows, so this one is zero. Okay, this one is zero, and the top one, this one, it is determinant. Just like you expect A from the J's row, right? Okay. So based on the definition, so this can be the second or the third one can be proved as relatively easy. Okay. So, what does this tell you? We actually previously, hey, there's this, right? Previous, we talked about this like, okay, if B is obtained by, from matrix A by doing an elementary row operation, okay, it is going to be like, B equal to some elementary matrix times A, right? Remember, for example, like if you want to switch two rows, okay, say like 3 by 3 matrix, you want to switch a row. The elementary matrix will be like, say, if you want to switch the first row is the second row. So it's going to be 0, 1, 0, 1, 0, 0, 0, 0, 1. Basically, it's like, if you multiply your A with this one, okay, the first two rows automatically gets switched. Remember, we talked about this. Right? Right? We talked about this. And if you want to, for example, multiply the row by certain constant, it's going to be like, you are doing, say you want to multiply row 2 by constant C, it's going to be so just like you multiply the A with this one, and you get like the resulting matrix, right? Okay, and yeah, the third one is single. Okay, so basically just like whatever operation you want to accomplish, you just like try to do it on the identity matrix, and then multiply that identity matrix to your matrix A. You are going to obtain the same effect as like doing that elementary row operation on the matrix A. Okay? So once you understand that, so let me ask you this. Okay, let's take this one as an example. What is the determinant of this? For identity matrix, you switch to rows. What is its determinant? What's the determinant of identity matrix? Huh? 你们不是应该今天理论上要讨论什么？说你问好像你们知道什么叫 identity matrix 吗？ That everything is zero except the diagonal elements. They are one, right? That's your identity matrix. Okay, so determinant of identity matrix is one, right? And then if you switch two rows, according to our theory, what will be the value? Huh? Negative one, right? Okay, you can verify this here. You can verify this here. Okay, you can see that all the this direction. Okay, the positive part give you zero, except this part. This is then the negative, term is negative one, right? And that's what you learn by how we calculate like 3 by 3 determinant. Okay, but anyway. So, I mean, for this one, the determinant of this one obviously is C, right? Is C. Okay. And then the third one, I mean, you can give it a shot, but the determinant will be just the third one, okay. It's like you are say we multiply the second row by the constant C and add to the third row. It's going to be I mean, this is still a triangular matrix, right? For triangular matrix, this is actually a lower triangular matrix. Okay. And for any triangular matrix, I mean, the determinant will be just like you multiply the diagonal elements. And so it's going to be 1. Okay, so why do I need to talk about this? Because, okay, say we know we apply one elementary row operation on A, it's going to be like B equal to BA. Then the determinant of B happen to be determinant of E times determinant of A. Okay. So, once you understand that, there is a very important consequence. Okay. I know like the determinant of B and the determinant of A. And if you can, obtain B by applying some elementary row operations on A. I mean, well, there are some connections between the determinant of A and the determinant of B. Okay, but they are not the same. They are not the same because obviously for this one, okay, second operation, it's going their determinant will be different by factors. For this one, if it's positive, change to negative. If it's negative, change to positive. So yeah, something is going to be changed. But one thing we are sure is that once we know this, okay, like if a matrix is singular, what does that mean by singular? Or put it another way, what do we mean by non-singular? Invertible. Yeah, there's an inverse matrix. Good. Okay. So, and from our previous discussion, if the matrix is non-singular, okay, you can use a series of row operation to convert it into an identity matrix, right? So in other words, and this is if you only, okay. In other words, it works on both ways, okay? A is non-singular. Then okay, you can apply some elementary row operation on A to get identity matrix. In other words, okay, so you apply E1, and then apply E2, and then you apply, well, EK, you apply K operations to A. Eventually, you're converting A to I, right? Right? And then if we try to consider the determinant on both sides for this equation, determinant of I, okay, on the left hand side, this is obviously 1, right? No question about that, right? So on the right hand side is determinant of